Mhm. Okay, let's kick off this week's community call. So I just dropped a quick check-in here. So we have our release on the go right after the previous release. So we're doing lots of releases, which is good. This one has got project sales support and also single cluster DNS and TLS policy support. I think the main outstanding item, there's lots of work ongoing, but the main outstanding item is a quick start script for the single cluster setup, which Adam's progressing. But the docs are pretty much in place. They're not merged yet because the quick start script's not there yet. But yeah, it's going well. So I think we'll probably get to Quadrant service protection fairly soon. I'm not sure when, but we cut ER1 for MGC. I don't know if anybody's got a view when 0.6 would get a ER, but shout if you do. Hopefully this week sometime anyway. Anyway, the point of kind of recapping that was, well, it's all great work that's happening, but I also wanted to kind of put out an idea that this is hopefully the last release for the year, barring some bug fix that we want to do. So I kind of want to take the opportunity to encourage people to take a look at some interesting areas in the next few weeks, or next week, or however long you're here, before the Christmas break. So some that kind of jump up in my mind, at least. One is around OCM-less multi-cluster DNS. So that's basically implementing like a registry in the policy controller to allow it to use the zone file as a coordination tool to coordinate between different instances of the policy controller across multiple clusters to manage the DNS records. It's one of the things. The reason that that's quite appealing is it means you can go from single cluster. I tell you, my dog just waits for this call. He's silent the entire day, and then he waits for this call. The reason that that's interesting and important is it allows you to go from like single cluster quadrants and potentially mirror the setup, and you will have multi-cluster instead of having to set up and install OCM in order to do multi-cluster. You should have a much simpler path towards multi-cluster DNS. So yeah, that's kind of where that's going. And then obviously we'll still keep the OCM integration and maintain and that kind of thing. But maybe for like larger deployments and more clusters. So yeah, that's one. And the delivery man's turned up. Can somebody else take over for a second? I'll be back in 1 minute.
Sure. So maybe, Guy, we could just move on to your point, and then we can circle back to Craig afterwards.
Absolutely. Thanks, Paul. So a few days ago, QE ran into an issue with reconciliation of the old policy that wasn't as much of an issue of our implementation itself, but rather kind of an inherent problem of the operator pattern and how people have been implementing Kubernetes custom controllers in general. And that caused basically what was perceived as an endless loop of reconciliation of a particular resource, right? And basically has to do with this comparison between an existing desired state, an existing state of a resource and a desired state of the resource. And whenever the operator spots a difference between those two, it performs an update on the resource, effectively performing the reconciliation, right? And the problem is that usually that comparison between existing versus desired usually does not take into account any occasional post-update modification of that resource, on that watched resource, right? Things such as a default value enforced at the level of the OAS, right? And enforced by Kube API server, or a mutating webhook that modifies the state of the resource. These kind of things that are performed usually post the update or the creation of the resource are in general not taken into account when you generate a desired state for the resource to compare with the existing one you find in the cluster. And whenever that happens, you trigger an unpredictable cycle of reconciliation where our operator compares the existing versus desired, spots that there a new update is needed, performs the update, and that other hook later on modifies this state back to something different that in turn activates our operator again, that once again realize another update is needed, and so on, right? And that loop, it's only broken, it's basically a race condition. When in case our operator happens to win the race condition or lose in this case, right? And checks that the current state is already the desired one, but only because that other hook has not yet updated the resource, right? Because if it's the other way around, it will continue on the loop forever. So that was perceived in the reconciliation of the Altarino alt config custom resource by the Kuadrant operator component. And we decided on that day to tackle the issue by basically just forcing a dry run on the update before, and therefore getting the actual final state of that, or that desired resource before performing the comparison with the existing one, right? And that basically solved the issue, right? So we have this pull request. Craig, do you mind if I take control of the screen for a moment?
Go ahead.
Thanks. So this works out. Yeah. So basically, this result in this change here, where we, I think this is the issue, right? Yeah. So here's the pull request, where we basically start doing this, right? We started performing a dry run on the update before going to the actual comparison between the existing versus desired, right? Obviously, that means an extra request to the API server to perform the dry run, which later on we got this response of trying to reduce the scope of that solution only to the situations where we know to actually need the dry run, right? It turns out that now this is open for discussion, right? And we have two different points of views about whether to move on with this change or not. One is try to reduce this overhead associated with the dry run first by only performing on the resources that we believe that could happen, such as in the case of the alt config. And another point of view is that we cannot really predict where that can happen, and therefore we are safer if we perform the dry run every time and just live with the overhead, right? And that's precisely what I would like to demonstrate here, right? So very quickly, if I go back to the agenda, I have a short demo of how we can simulate that endless loop here and how easy we can run into that situation as I understand it, right? So this is basically this branch, right? This is this branch, dry run first, reconciliation option, with only one minor change, only to make it easy to activate the issue here, right? So all I did was we have this controller that is part of the Kuadrant operator component, which is the one that watches for changes in the envoy filter, which is an issue resource. We generate this resource, and later we watch for all the events related to this resource, so we can reconcile from the gateway and down and make sure that the resource in the state we wanted it to, right? All I did here is I'm adding an artificial sleep here in the middle of the reconciliation. So as you can see, this is the where is it? Here. This is the reconcile function, right? I'm adding an artificial sleep here only so our operator always loses the race against the mutating webhook that I'm setting here, relying on gatekeeper. So this is a mutating webhook that whenever it perceives a change in the state of an envoy filter resource, it will patch it by setting this value here, the connect timeout that is part of the proxy configuration, to a value of 2 seconds. Whereas the one we generate is this one, right? The one that the Kuadrant operator generates, and this is the Kuadrant operator code. The one it generates sets a static timeout of 1 second for the connection between the proxy and limitator. So we want, through this mutating webhook here, to patch this to 2 seconds, right? So we have this created here. And if we create a rate limit policy here, and by the way, on the right-hand side, we are watching the envoy filter resource, right? Currently, we have no rate limit policy and no envoy filter created in this cluster. So we create this one. The Kuadrant operator will make sure to create an istio envoy filter resource, and one at first with a connection timeout of 1 second. And then the mutating webhook will change that to 2 seconds, right? And here at the bottom, you can see the Kuadrant operator logs. So when we do this, you should see here in a second that the envoy filter was created, and it was already changed the connection timeout to 2 seconds by the mutating webhook. And because of that sleep, roughly at every 3 seconds, you see an endless loop of reconciliation. That's basically our operator and the gatekeeper, a controller, fighting for the state of that envoy filter resource. So we don't need, obviously, the timeout there, to realize what's going on, right, or to activate the issue. The issue is activated only by creating the mutating webhook. So that shows one side of the story, right? And why not to move on with the change for the performing the dry run only on selected cases, but rather on all the cases. The other side of it is, as I said before, performing a dry run is effectively an older request to the API server and therefore an overhead. And yeah, I see people there, and looking at you, Agus, I know you have some thoughts on this one, but please, anybody speak up.
This is not quite. Sorry.
No, I just wanted to say that Guy explained very well both sides. I have few more to add. Maybe you gave me one reason more to support my idea to do this optionally. But I think you explained very well. I think people have enough information. I would like people to give feedback, maybe not now, maybe later, but whenever. I think people have enough information, and so when we reach some quorum, some common sense, we can implement that. Craig, go ahead.
I was going to say, it's just like seems like a common controller problem rather than something specific to the Kuadrant operator, right?
Well, yeah, it's a good question, right? It's a common problem. Not of the controller runtime, but whenever we implement custom controllers based on this pattern of reconciling to a desired state, but only because that's usually how it goes, right? You compute a desired state and you compare that with the existing one. And usually people forget that the desired one may also include things that are out of your control, like those hooks, right, that modify the state. So that is the problem. And we've been running some some searches on the web, and we've been finding many people complaining of the same problem. And that's how we got to the dry run approach in the first place, actually. So I think that that's just a common issue that for which we don't have too many good solutions, I'm afraid.
And is the downside here that basically we're creating double the amount of requests to the API server because we're doing a dry run and then we're doing an actual commit?
That is correct. Also, on that point, I would also add that yes and no, right? Because if you are now considering through the dry run that the desired state also includes things that you do not control, and then you are comparing to the existing ones, sometimes you will decide not to update because of that. Whereas without a dry run, you may decide that an update is needed, but that will cause yet another one. You know what I mean? So it's really hard actually to predict if that is increasing or doubling the number of requests you perform. Just not necessarily. Sometimes you avoid performing the update because you realize upfront that an update is not needed. Yes, Gus.
So yeah, to summarize my my point of view very briefly. One is wanting to avoid this extra traffic load when we want to update some service. That's the first point. Second point is this problem only applies when you compare two objects entirely, when the reconciliation has the capability of we can implement that. We want to reconcile only when some fields change, not all of them. You may not want to reconcile when there is some extra annotation you don't control. You may allow others to add annotations, and you don't want to be strict or opinionated on the annotations that an object can have or not. So that's the second one. So doing some other kind of comparison between existing and desired may save you from this dry run. And the third one that I didn't have until I saw your demo is that the external webhook can be evil in the sense the operator is can be opinionated in the spec, saying I want this field to be 1, and an external webhook it's saying it is going to be 2, but the controller wants it to be 1 because otherwise the deployment is broken or whatever side effect may happen. So it's even healthy. The controller is trying to update again and again and again because it's his way to make this healthy according to his perspective. So same happens for defaults. So we need to be clear. So comparing desired with existing and having desired being mutated externally without any knowledge on what those mutations are about can be also kind of risky at the very least. So those are my three points.
Yeah, allow me to reply to some of those, right? So you mentioned about comparing the entire resource versus only specific fields. I myself said that the other day when we were first looking into this issue, and it took me a while to realize that that is not really the case. In fact, it only takes is one single field that you care about. If that single field happens to be modified by something else, you already run into the problem, right? Such as in the example of the timeout. Let's say we had one explicit line of code to check that would check only for the timeout because 1 second matters for the quadrant operator, right? And that is what you want to enforce. Which leads me to your last point, right? If that is indeed what the quadrant operator wants to enforce, and that is the value we want to set, then I don't think that this constant or this endless loop of fighting against something else is the way to communicate to whoever is operating that cluster that something is wrong. But rather, if that is the case, of this is something that is very important for Kuadrant to function, then I think that becomes an RBAC problem, right? So you should not be allowed to set a webhook that modifies, a mutating webhook that modifies that value if that is important to Kuadrant. So I don't think that we should allow that that our component, our product, to get into that state, but rather we should list all the things that are really, really important for Kuadrant to work, or the state that is desired, and then let for whoever owns those clusters to set the RBAC. Including, we can give some templates for that to happen. But I don't think that is the kind of thing that it needs to be enforced inside of the operator. But I'll let somebody else to speak. Hiram?
Yeah. I mean, I think those are all good points. Like for sure, like after you get your dry run result back, you can basically, you could analyze, oh, hold on, something's changing in fields we want to set, right? And then you guys could just change the status to be like, hey, there's a conflict with something changing one of our fields. We're not going to continue to reconcile this object until you guys fix whatever it is, right? Like you guys could just basically stop reconciling that guy until you guys and just set a status to let people know, like, we're not reconciling this because there's a conflict, right?
I think that's the purpose of the manage field of all the Kubernetes resource. It's saying, hey, I am the owner of this field. Nobody else should change it because I'm the one setting it. So if we respect those or honor those fields, or everybody respects those fields, no external mutating webhook should change any of my fields, because I'm specifying I own this field. I want to be one. So if somebody is changing to two, it's tricky.
The API server doesn't enforce that, right?
Let's also remember that somebody can also be the Kube API server itself because of some default, right? So if we want to cover for that, that means in our code, we would have to duplicate all those defaults as well, right? We would need to enforce those defaults in the desired state we compute in order later on to be able to compare and not to flag that as a difference.
Agree. I mean, the defaults are owned by the operator or the controller. So yeah, and it happens that we need to duplicate it because you specify those at the OAS, OpenAPI specs, part of the CRD, but also as a Go code, you need to create those objects with those defaults. But yeah, it's unfortunate that we need to duplicate, but maybe I tend to think that is what we should do. Yeah.
What do you mean by the defaults are owned by the operator?
The CRDs, the owner of the CRDs are the operator, right?
Well, it depends, right? Say it's the Istio envoy filter CRD, for example, right? So Istio in this case owns the CRD. We may own the CR, but Istio owns the CRD in the sense that it's
Sure.
under their control what they set as a default or not, right? So effectively, what I'm saying is we would need to be aware of all those defaults enforced by Istio in their CRD whenever we move to a given version X of the CRDs. So when we create a CR, we need to also take that into account for our reconciliation of the CR.
Yeah, exactly. Or if we know that there is some default, we don't check if our desired value is nil or not set, because we can expect some default to be applied. Yeah. We have a version. We work against a version. We know the versions of the defaults for that versions particularly. Yeah.
I like the idea of somehow trying to flag that the system is in that state where more than one party is racing, to win the final state of the resource. I like that idea, right? I don't know if it has to be in an endless loop, or once we flag to that state, we stop, right? But maybe that's not possible. Maybe what you need to do is, okay, you dry run, you compare, you realize there's a conflict, you set that state, but you need to keep watching, for something to happen so we can try again later on.
Yeah. Another thing that worries me is, does this mean you always have to dry run on every reconciliation loop?
Yeah, and the source of all the concerns that led, to the pull request that we're discussing, right? Because basically that's what we're doing right now. All the updates we are dry running first.
Yeah, it's because like typically I think a lot of queue controllers don't do that, right? Like
Yep.
they pretty much, that's why they even have the informer cache and all that kind of stuff, so that way they don't add additional load onto the Cube API server.
Correct.
So it's almost kind of like maybe we can create a cache if we had an additional cache. So we got our desired state, we run the desired state against the dry run, we get that version of the dry run, which could fill out other fields. Can we just kind of associate those two things as being equivalent and store it in cache? And then later on, when we reconcile again, if it's still the same desired state, we find that thing in our in our cache. We get the the dry run thing that we got from last time. And if it's still what that thing was, then hey, we can skip the update, because if we dry run that, we're going to get the same thing again. You see what I'm saying? So that avoids having to do too many dry runs. If basically if we got the same desired state, we're going to get the same dry run result. You see what I'm saying?
Yeah, I think I follow. Yeah.
Like if we consider the dry run to be, repeatable, it's always going to give us the same result for the given input, then I think we can cache it for the given input.
Yeah, as long as you don't change the CR, the cache should be valid. Yeah. Only when you change the CR, you can expect to have a different result from the dry run.
Yeah. So maybe that's what we need to do.
That might be another way to solve this. Yeah.
I'm getting a little hung up on the point that Iguski pointed out, which is if the operator needs a particular value to be one, if it's very opinionated about that, then it can't really tolerate then the concept, right? That, well, okay, something else has said it's 2, so I'm just going to let it be 2. That's not a tolerable situation. And it's the same problem then if we are detecting that scenario is occurring, then maybe both the hook and the operator both can't tolerate the concept that it's a different value. And so which one of those is ever going to say, oh, we're in this scenario, let's stop editing the resource? It feels like neither would.
So I think that there's like several scenarios here. There's that one where you have a change to a field that's conflicting, like 1 or 2, whatever, right? That one's bad, right? And then you got other ones where it's kind of like when you don't set a field and then you get the default back, right? Where we're okay with the default. You see what I'm saying? So we're okay if you change it to something else. So I think the idea of having a cache to just like fill in the defaults with the dry run defaults, and I think we sort of need to analyze the fields that got changed to make sure like it wasn't something that conflicts, and that might be a little tricky and hard to figure out.
Well, the cache has one downside, which is if the resource is externally mutated by some third party you don't control, you cannot rely on the cache as well, because for the same desired value, you could have 2 different and different values in time, because you don't know why it's mutating or in which logic is mutating the values.
Yeah, but it's only mutating it from the last desired Well, I guess that assumes that you're the only one that's mutating it and writing it.
I don't know if I'm wrong here, but I don't see a way out of the dry run. I mean, the only way we can realize that the final state will be something different than what we want is by dry running it, right?
Well, I'm saying that like you can avoid the second dry run in your reconciliation loop. So you have one resource, you got desired, right? You dry run it, you get the actual. You cache the key of the cache is like the desired is equal to the actual, right? That's your cache, right? Now you do another reconciliation loop, right? If your desired is still the same as your previous desired, then you say, well, I'm not going to do the update because it's still the same. No? Like,
Right.
and basically the output and what you see from the cube, like informer, is like the actual matches your actual, right? It's like, oh,
Gotcha.
it hasn't
Yeah.
changed since last time. You know what I'm saying? Even though I want something else, that something else is going to turn into the actual, and it hasn't changed. So I'm not going to do the update, and I'm not going to do the dry run again. See what I'm saying?
Yeah, sure. But back to my point, what if the mutating webhook adds timestamp to some field?
Sure, but we're not calling the update, so we're not mutating. So the mutating webhooks is not going to be called.
But your cache will be outdated in the moment you create it.
The mutating webhook is not getting run, so it's not modifying anything.
The second time, yeah, I think I follow. So the first time we need to compute what will be the final state of the resource, and that's what then we perform the update or create, and we save that, we cache that somehow. The next time we compare the fields that we care about to that cache, and therefore we do not need to perform a dry run again. So if it's different from the cache, we perform the operation.
Right.
Otherwise, yeah, we don't.
But again, the
But
cache
we
doesn't
need
solve
to.
for some
Yeah, we need
specific
to-
cases. I mean, if there is a mutating webhook setting as timestamp, the existing will have the new timestamp, the cache will have the old timestamp, and it will not match, and you will do an update.
Well,
And
you can
again,
catch it. I think that scenario, you would even catch it on your first iteration of the reconcile loop, because you're going to get your dry run's going to give you one output. You're going to do the update, and you're going to get a different output now, right? So basically, your update gives you back your object, and that object's going to be different from what your dry run said it would be, because the timestamps are different. So on the first reconcile, you could say, hey, you got something here that's modifying your shit, and maybe we can, whatever fields get modified that are different between the dry run and the update, maybe we can just like put them on a list and say, ignore these fields.
I can see a good tool for detecting mutating webhooks or things that are changing fields that you expect or you control or you want to be opinionated about, and say, hey, somebody else is changing something that I should be the owner.
Yeah.
Also important to highlight that there are cases, there are structures in the resources we manage that we cannot that we do not know the schema upfront, right? There are many cases where it's just an open struct, and yet we need to reconcile to that state. So I think to those cases we simply cannot avoid, right? Such as even in that case that I just demonstrated, right? The part of the timestamp that we are setting, it's part of an open struct, right? It's something that Istio will just carry along to the configuration of the proxy, and it's not specified in the Istio API itself, right? So parsing that and treating that as a a first class certain field might not be as easy. And we have others that are even impossible, things that are completely user defined, right? Such as in the case of the auth policy and the auth config, where the user chooses the structure, and there's nothing we can do, to verify individual fields. So rather, we need to check the whole thing. Thomas?
Yeah, I'm just wondering if we should be solving this problem. Like, I think somebody said it already. Like if it's a Kubernetes level problem, should we actually spend time solving this in the Kuadrant context? Because that every project would be solving this problem in a different way. It doesn't seem like something we should put energy in. It's just users will know that this is a problem of the way and how things work. Like, okay, if you target a CR directly, and you can expect the controller to hit on it, like, not our problem. It's a problem, but not ours. Maybe I'm wrong.
Yeah, I don't know if I agree 100%, Thomas. I think Kubernetes has been beat enough lately about security, right? And people are coming with all sorts of explanations about why Kubernetes is not safe enough. And what you do not want is one demonstrating that risk with a component that we deliver, right? So I wouldn't want to see Kuadrant on the spot because someone showed that our component can go into an endless loop because of some safe default we did not enforce, right? So that's why I see this as a security issue for our product.
But it's also just a problem you could just hit, right? Like if certain managers installed, for instance, and this code validating replicate and it's doing something, then you create a certificate and you reconcile the certificate. Like you could just hit it and you have to solve it. Like you might not have a choice but to solve it. That's where I'm coming.
I think this is a problem that's not unique to us. I think most all controllers have this problem, and I think most controllers probably do not handle it well. I'll just say that.
I definitely agree with that.
So while I do think it's good if we do it, I don't think it's 100% needed. Like whoever installs the mutating webhook is a cluster admin. Like cluster admins can fuck up their clusters by nuking the whole cluster if he wants to. You see what I'm saying? So yeah, I do see value in being nice and recovering from these failures and letting the cluster admin know that, hey, you fucked up. But do we have to do this? I don't think we have to, like day one, just because, like I said, like I think most other controllers would fail in this scenario too.
I think the question here is how far we want to go, right? Right now, the state is we are dry running all the updates so we can mitigate the issue, right? And take into account those possible changes that may happen. With a follow-up request on not doing that for all the updates we perform, but only to one that where we already spotted, a critical issue of the endless loop.
Yeah. So like what I would say is I would focus on the case of, for example, working with structs that you don't know the default for. Like this whole dry run stuff is cool. I would say don't worry about trying to solve the problem of something else fighting with you. Just let it, cycle endlessly. And, for now, because I think all other controllers would cycle endlessly, right? I would say try to deal with the defaults case better. That's the one that's very common, and you shouldn't get yourself into a loop around, right?
As of today, ours will not, right? Cycle endlessly. Ours will just give up as soon as it detects that there's another change.
Okay.
With a nice error message.
Come again, Thomas?
With a nice message that makes me understand what just happened.
Yeah, that is the part that we are missing, and yeah, and I like that suggestion from Hiram that we should be able to flag that is the state, right? Okay.
So sorry, Guy, so are we only doing it for one particular case now, or are we doing it for all cases? I didn't quite follow that part.
Well, right now the code in main branch is for all, right? And we have an open pull request to limit it that only to the alt config request, to the alt config CR.
Yeah.
And I would say you probably do want to put in that cache in there, so that way you only do our dry run once per desired state. You see what I'm saying? Like when that desired state changes, then you do another dry run. But let's not kill the API server with the dry runs, like especially because you do periodic reconciles and stuff too, right? So.
If we're just talking about not a scenario where the hook and the operator both want to change the same field, but rather the hook is setting a default field that the operator isn't doing anything with, I'm not seeing how that's an endless loop. The way I follow that is the resource is created without the field, the operator updates it somehow, and that goes into the API, and the hook adds the default field. Then it reconciles again, but the default field would be present, right? Why? The only way I can see that being an endless loop then is if the operator is taking that field out or something.
It becomes an endless loop if the operator includes that in the comparison, right, between the existing versus desired. If the operator does not care about that field, then we just ignore that, and we would not flag it as an update is needed, and we will not perform the update. So you're right. If the operator does not care about the default field, and we do not include that in the comparison between existing and desired, we're fine. So the problem is when we do include it, and sometimes we do include it, I would say by accident, or because we do not, we cannot see all the details of those structures because it's an open struct, right? This kind of situation. So there are cases where we have to compare the entire resource or an entire bit of the resource, and yet some default is being set under that level.
Okay.
And some of it is like lazy comparison, right? Because it's very common for, and I'm not saying about our controllers only, but all controllers like do, semantic deep equal or reflect.deep equal. There's no like, check this field, check this field, check this field,
Yeah, I think what I was trying to say before is that it's that deep equal is either lazy or the only way. When it's the case of it's just a lazy measure, then let's try to be more specific about each field that we care about.
And also we don't implement defaults, because another way to solve the issue in the Kuadrant operator is to implement the defaults, but we didn't. So this is another way of solving it. The thing, my point against is that it's something that affects all the resources and all the reconciliations. So my PR is saying, okay, you want this for the health config. There is an option, you a flag, you enable for the health config, and you have it for you.
But I think that was my point, right? It does affect all the resources. I mean,
potentially in the future, not now.
No, that's not true. As I showed before, right now, all it takes is one mutating webhook, and you activate the issue.
Changing fields we are opinionated about, or the controller is opinionated about. That shouldn't happen. And this problem, that problem cannot be solved. Two controllers trying to update the same field, this is unsolvable. I mean, there is no way.
You perceive that as opinionated, but that is a field that our controller cannot check individually. You know what I mean? So it's not opinionated. It's just because we cannot check that individually.
Yes, you can. I mean, it's depending on your logic. You may say you may decide to check individually all of them, or just say whatever is there is raw data. I don't care.
If it was a WASM plugin, I chose to demonstrate with an envoy filter. But what about a WASM plugin? Right, a WASM plugin contains elements there in the values that are defined by the user defined. Right, so we do not know. We cannot navigate those fields individually to compare and say, you know what, this is the state that we want. When at some level we need to trust that whatever we got from, let's say in this case, the rate limit policy is what we want in the WASM plugin, right? But that does not prevent anything else to later on to modify that state.
Exactly. So if somebody externally changes that thing in the WASM plugin, the operator needs to revert those changes according to what is in the rate limit policy.
Well, what I'm saying is what you just said is an RBAC problem. It's not a reconciliation problem. Who should win that fight is an RBAC issue. It's not a reconciliation issue. I think that's my how I see the problem. So if it's not for something else to modify that field, then it should be forbidden in the authorization rules of Kubernetes. But if the authorization rules allow you to do that, then you are saying it, right? That supersedes whatever the controller is trying to do.
Yeah, and because of that issue, we are going to reconcile two things that we don't even know what is in, because we are comparing one thing that it's an existing thing and one thing that it's a desire but has been mutated unexpectedly. So
it will be mutated anyway.
The controller, well, if it's mutated, the operators will say, hey, I'm here. I'm detecting some mutation. I cannot do anything about this, so I stop reconciling this.
I don't know if I see it the same way. The controller sees some mutation will happen and accepts it, right? And allows a mutation because someone with permissions created that mutation. So I think what I'm saying is our controller should accept that that mutation will happen and accept that as part of the desired state.
No, because it can break your deployment. No.
If it can break your deployment, you should not have permissions to create the mutation in the first place.
If I want one thing to be one, it needs to be one, because otherwise my thing it's not working.
Who is you? Who is you?
Me, Quadrant operator. Deploys
yeah,
Quadrant.
But who says that the Quadrant operator has more power than whatever mutating webhook that's modifying that value?
Not sure I follow. We are elevating this problem to some permission that maybe out of scope. I don't see it. I don't know.
I don't think we are elevating. I think it is a permission problem from the beginning.
Yeah, so I think the biggest problem with this, like, so for example, if you run this through the dry run and get some different output out, I think it's okay with just trusting your shit's gonna get stepped on every time, and that's gonna be the output, and you're never gonna win, right? Just accept it. You're not gonna win that race, right? The one that we do need to step on is when we see a change from the API, like we see that resource change to a different value, like somebody manually edited the resource, we need to step on that one. But I don't think we can ever win the output of the dry run.
I agree. I totally agree. That's why we can tackle the issue with the dry run, but that's it, just a dry run. Obviously, a manual update, it's not covered there. A manual update will trigger reconciliation, we'll dry run, there's nothing else, we'll reconcile back to the desired state.
And like we can get into a reconciliation loop here too, because like there could be other controllers that are effectively doing manual edits, right? They could be editing the resource too, right? They shouldn't be, but you know, and they just keep flip-flopping back and forth. But there's no way to detect that either.
You're right. Yeah, that would not be covered by the dry run. Yeah.
You are effectively saying that the desired object of any controller doesn't have any meaning. for the operator, for the controller, because it can be mutated. So we are comparing. Why do we even care? I mean,
Well, it can be mutated if you, as the owner of that cluster, granted permission for somebody to set the mutation.
okay, yes. But I mean, if the desire is desire, it has some semantics. I want this field to be 1. If somebody else can change to 2,
What if somebody kind of says, you know what, we really love this Quadrant controller, it's really awesome, love it, but it does this one thing that we want to change a little bit. Oh, I know how to fix this. I can put in a mutating webhook and adjust what it does. And then they're happy with our stuff because they have this mutating webhook that adjusts what our controller does.
And I honestly believe that the example I showed before is a very good example of that, right? We decide to set a given a timeout for the connection to limited door. Let's be realistic. In a real life scenario, somebody can realize that that hard-coded value might not suffice, and then you may need to change that to something else. As of today, there is no way to change that. So the way to tackle that would be create a mutating webhook that modifies that value.
No, because that field is owned by somebody else. You cannot start changing the resources of the SSO of the everything in the cluster.
I think basically you're saying that the controller should be more powerful than the owner of the cluster.
I'm saying that the controller owns some fields and it's specifying those fields and they shouldn't be changed. And if they change, we have a conflict which is above controllers. It's Kubernetes conflict, permission conflict, as you said. But that's the way of the controller to complain about that is detect it and generate events or in the status or whatever. But I don't want to be comparing 2 things that I don't even know what they are. Desire and existing. Who cares if they can be changed externally? No, they cannot be changed externally.
I think we are in a loop here in this
Yes,
section. I'll open up
sure,
to more.
Sure.
Maybe Roy.
Sure.
Oh, no, I just wanted to say that I agree with Agus here. I don't think mutating webhooks were thought to solve this kind of stuff, like a user changing some stuff he doesn't like or he would like your API to support. I think the way to go is, okay, please support my use case in your API and not just doing it.
So we got to keep in mind, this is not a regular user. This is a cluster admin that would install a mutating webhook.
Well, yes, you are a cluster
admin.
admin.
So this guy he's the one that has total control of this cluster. And you're saying that you're not going to give him the control he wants because you think you know better than him. Are you sure you want to do that? I think it's okay if they do that and we detect it and basically say, hey, we're not going to, if you file support issues with us, hey, you have a mutating webhook, we could highlight that and say, hey, support, you're on your own. You know what I'm saying? But
I personally have been in that scenario, just never being clustering of a lot of admin of a lot of clusters. I've never had this use case.
But like for example, Cert Manager, Istio, they all install mutating webhooks, right? We're going to create one of their resources and they're going to mutate the resource when it comes in. Are you saying you're not going to honor their mutations or they're doing the wrong mutations?
I didn't follow there.
Cert Manager installs mutating webhooks.
Sure.
So does Istio. If those guys mutate the resources that we're reconciling, are we saying we can't work with those products?
Oh no, you should. But you are using Cert Manager, so you should really take into account the mutations that they do. But I don't think you should support any random user writing the wrong mutation webhooks. I mean, you are working with a piece of software that it's the controller and the mutation, and you should take that into account.
No,
And
I'm
you
just
should
saying, like,
honor the limitations
what
of,
you're generating, like the resource, your desired resource state does not match what the actual is going to be, because the mutating webhook is going to change it. This is the scenario here. So are you going to step over the changes that Cert Manager
No, you
is
shouldn't.
CO'd?
No, you shouldn't. You should just
Okay, so
reconcile the fields
why
that
is
you
it so
care
why is
about.
it okay for that but not for other scenarios?
Because it's
And are you going to have a whitelist of which ones you're going to allow this for?
it's controllable, it's maintainable, because you know which fields you need to enforce, and you know which fields a manager is going to mutate. But it's impossible for you to know what fields a random user or random cluster admin is going to mutate. That could create just havoc. It's I don't know. It's too hard. It's too difficult. If
I guess what we're saying is we've come up with a way to tell by doing our dry run. We can tell by doing the dry run. We know if the mutating webhook mutated or not. So it's not impossible. We have a way of doing it now.
But how do you solve the conflict? I mean,
you accept
can
that
detect it,
you don't resolve it. You just accept that they stepped over you, and you use that as your desired output.
And if that breaks your deployment and everything stops working because the user touched something that he shouldn't?
If that breaks the deployment, then it's on whoever created that mutating webhook.
It's going to be broken anyway, right? Like it's going to just keep flip-flopping constantly. It's broken. It is, you know. But I wonder, like it feels like it's got very specific characteristics about it, right? Like you create a resource, you set the values, it flips back, you flip it back, right? It feels like you could observe that and then start applying a dry run, right? As in something weird. We've entered a weird situation. I'm observing this, and I'm going to apply my dry run because I think I'm in this bizarre.
It's easier. It's more easily observable if you are from the outside than from the inside, from the perspective of the controller. But I know what you mean. From within the controller, it's very hard to detect that you are in this state of continuously fighting something back, right?
Yeah, you would need a metric or something stored in memory.
Yeah. We are
you
out of time,
would know right away. You would know right away on the first update, because the update's going to give you back an object, and you compare that from what you tried to update it to, and you say, "Oh, it changed." So right after the first update, you'll know that, oh, something's stepping on my changes.
Right, unless what you did was to try to override that, right? If you try to override that, then it becomes hard to detect because you're back to the loop, right? So I agree with you if you do not try to override that. So the first one, this is the desired state. Second time, something happened, you compare, and you see what, hey, I wanted this, but for some reason it's different. But you do not override. We are over time already. I'm sorry about that. But we have other people that wanted to share. Didier, I think you had your hand raised.
Yeah, like many times. But the thing is, like then it was actually on the back and forth between Iram and Roy that some of the things that I wanted to share, they were like discussed there. So I'm actually okay. I was actually wondering something that wasn't completely talk about. It was about, I agree with you that this is actually an airbag situation. Like sometimes, of course, in the example of like having Istio and the Cert Manager, like we are going to be like we are actually sharing resources there. But I was wondering if you knew, Guy, or someone else knows, like how within the operator, within the controller, to know that there's like certain other clients that they have like or services that they have like a higher priority or have like a kind of like better suited role for the, between quotes, ownership of those resources.
There are a few things like the ownership of the resource itself. There are the thing that Agus mentioned about the managed fields. So I think there are a few things in there, but I'm not aware of anything other than that, right? Such as some way from within the request to send to the API server to identify that upfront, right? That you have more authority over that resource than any other. So I don't know. Right?
Probably Roy, since you raised your hand.
So I already commented in the chat that managed fields it's tied to the server-side apply feature of Kubernetes. This I believe is not fully supported by controller runtime yet. There's an open issue from like 3 years ago, something like that. And server-side apply, it's intended for several controllers or several entities to collaborate on managing a resource. So it keeps track of who owns a certain field and who not. But it still doesn't solve the case of a conflict over one field. Two different entities trying to write the same field. There's no priority, there's anything. It's just if you try to update a field that's owned by another controller or whatever, it's just going to give you an error and you have the option to override, but that could cause the same problem.
Right.
Thanks for sharing that, Roy. Anyway, sorry, Didi.
Yeah, so thank you. Yeah, so I think like we're gonna have like the issue when there are like disputed fields, like no matter what. So in that case, you know, for the rest of the cases, we probably we need to be smart in the terms of like doing the comparison if we're going to with the desired object and not doing just the div equal. And sorry, they're like knocking at the door.
It's okay. I actually would like to propose for us to try to put a pin on this topic for the time being, so we can do some more research, some more studying on it, and see if there are other possible ways to approach this. The current state of thing is relatively safe, although slightly more costly, right? So I don't say that the proposed enhancement should be completely rejected. I think we should take a look into it. But as of today, it's more about performance than an actual bug, an actual issue, right? Actually, on the contrary, right now what we have is we fix at least that problem, right? That was first identified by QE, and as part of the same fix, we fix that from that to happen on any other kind of resource that we manage. In the meantime, maybe we can keep on investigating this and trying to find some better ways to approach the problem, either the cache thing proposed by Hiram or whatever. How does that sound?
It sounds good. I feel like the cache, I simply don't see how it's going to be an extra benefit if we are not actually already, you know, with dry runs and being smart in the comparison of the objects, you know, I think it will be enough until we find like a better solution. I don't see how in the long run a cache it will be of any help in terms of performance in this case.
I think there are a few elements there that we can use, right? I think that somehow connects to another thing that we've been doing, which is the DAG thing, right? And try to approach the events coming from the cluster in a different way, where we kind of trying to keep a copy of the state of the underlying topology that we act on, right? And that is kind of the structure we navigate and we check, right? So I think there's something there as well that we can connect here. I also like the idea of somehow being able to flag that the system is running into that state, right? Rather than what we currently do. Because right now, either we completely gave up, which is the current state of things, or the previous one was we let it go into an endless loop, right? I think there might be something in the middle that we can work on. Something like, okay, we detect there's a problem here. We can be opinionated, but for some things, we can give up for some others, and that is all configurable.
Okay, sounds good.
Yeah, Agus? And the final words on this?
Good. No. Let's progress on this.
Thank you. Thank you all so much. And sorry for taking a little longer than usual.
It's interesting. Thanks.
Cheers, everyone. Bye.